Hello and welcome everyone. My name is Raquel Heredia. I am Senior Program Lead for Strategic Partnerships at World Nuclear Association. And as we prepare our road to COP30 in Brazil, we're highlighting the work of our industrial partners. So today, I'm delighted to be joined by Magnus Mori from Urenco, one of our trusted partners. And we're going to discuss the release of the report, A New Nuclear World, How Small Modular Reactors Can Power Industry. So Magnus, can you please introduce yourself? Tell us a little bit about your role at Urenco and a little bit about the report.
Sure. Thank you, Raquel. So my role at Urenco is really to lead Urenco's commercial strategy for advanced fuels. What does that mean, you may ask? We define advanced fuels as all the fuels that need an evolution or a development of the current supply chain. So whether it's higher enrichment or new chemical forms or new delivery methods. This function has been in place for a few years as you recognize the potential of the market for SMRs and advanced modular reactors in general.
Fantastic. And would you mind introducing the report a little bit? So what are we looking ahead with this report?
The main reason why Urenco decided to commission this report was to address the potential of the SMR market. We see that it's a market that can be very dynamic, that can evolve very quickly, and potentially it's a market that can evolve so quickly that we may need to think or rethink the way we do investment. So we thought, let's validate some of the data that we see and some of the demand signals and do a broad report to assess the potential of the SMR market. And we commissioned then Lucy to perform this.
It is truly a market that is exciting everybody around the world, and the report has some key interesting findings. Some of those are the potential for the SMR market for industrial users. So that is one area that we take a lot of importance here at World Nuclear Association and of all of our trusted partners. So you're looking into Europe and North America, and the report concludes that the market could be something around the 700 gigawatts by 2050, which is a very interesting number. So what is the significance of this high scenario that you're putting in the report, and how realistic is truly given the transformation and current deployment that we face in the industry?
So I'd like to start with the low case scenario. Just because it gives you it gives you a sense for what we're talking about. So the low case scenario is a forecast of, if you will, only 7 gigawatts by 2050. But that means, for instance, for Urenco, a doubling of our investment in advanced fuels. That also shows that for the transformation scenario, that's what we call it. If all the enablers are in place and all everything lines up, the accessible market, then we define it. We estimate it to be up to 700 gigawatts, which is 100 times more. It's just to give a sense of reference for the huge and really enormous potential of this market. How do we arrive to that number? We did a screening and selected 11 industries. These 11 industries, according to our analysis, represent about 80% of energy demand, industrial energy demand in 2050. And indeed, some of this demand is not just for electricity, it's for heat and for industrial use. Some of the industries that appear and that are most prominent in that demand profile could be coal repowering. A huge potential is also in synthetic fuels and sustainable fuels. Data centers, obviously, that's more electricity. We also have oil and gas, the food industry. So we looked at a very, very broad spectrum of industries to arrive at that number.
Okay, that sounds very, very interesting. So, the value case for nuclear very well. It provides reliable, affordable electricity 24/7, and as well heat. That's one of the services that it can provide. It can be very beneficial to the carbonizing of the entire economy, as you were mentioning, with these 11 industries that the report is looking at. That's very interesting. Um, but today, nuclear energy is in the relative stages of partnering with other industrial sectors, which is something that the industry is really excited about, because it will allow us to achieve this tripling that we're ambitioning, and this would be really beneficial for the further deployment. So, how does nuclear compare economically and technically to other clean energy sources for industrial applications, particularly when we're talking about heat and electricity demand?
That is a really good question, and not a question that can be easily answered, because it has to be the answer has to be based on different projections. We mentioned, and you mentioned, heat is a major component that will be required more and more for these industrial applications. And just to quote a project that is one of the demonstration projects out there, the X Energy Dow project in Texas, that nuclear power plant will deliver both heat and electricity because Dow needs heat for its processes. That is clearly something that solar and wind cannot deliver. So there are all of these cases where nuclear has a distinct advantage. What the study shows, depending on the different supply avenues and the different pricing scenarios, is that we could achieve pricing level of $40 to $60 per megawatt hour, which would put the nuclear on a very, very high competitive edge.
Finally, World Nuclear Association has helped lead an ambitious coalition of industry, governments, and financiers in support of the goal of tripling nuclear capacity by 2050. What actions are most urgent today?
I think the most urgent action for me is streamlined licensing and harmonized regulations. That I see as a major enabler. Some of these small modular reactors have incredible benefit if they can be indeed modularized and therefore deployed in different jurisdictions at scale. That's where those economies of scale come into play. So that's definitely something that I see as a priority.
Well, thank you for all of the perspectives you have been sharing. Is there anything else about the report you would like to share with us and highlight?
There's an important aspect. The report identifies 4 supply scenarios. One is based on traditional building of a modular reactor. It's more about site construction, very, very, very bespoke. Then one of the scenarios looks at standardization of the construction. The third scenario looks at modularization. And then the fourth scenario, which we also call the transformation scenario, looks at mass manufacturing. What I've noticed discussing the report with a few colleagues is that there's the impression that these scenarios are sequential, but they're not. We see some SMR developers that are already working in the, if you will, in the transformation scenario area, where the reactor is designed from the very beginning for mass manufacturing, while we have some other technologies where they're following more a step-by-step approach, and they're more in the first scenario where you have conventional bespoke construction. To conclude then, we started discussing the potential 700 megawatt. I mentioned the low case scenario 7. What I want to say is that because of what we see is that it's definitely between the two. So it's higher than 7, lower than 700. And what I can tell is that it's happening.
Well, that's certainly very exciting news for us to hear. And I'm sure that everybody in our road to COP will be very much looking forward to seeing these scenarios a reality. So thank you so much for joining us. Please follow our journey at COP30 if you'd like to find out more about the work that our industrial partners are doing and what we at World Nuclear Association are doing. Thank you so much.
Thank you.